Okay,
So
cool.
Peter is actually one of the main contributor of SpeechBrain. Like he developed a lot of things, right? So he's now he did his PhD, and now is actually working in industry, like for JP Morgan. And so Peter, please move on with the presentation. He has to switch on the microphone. Okay, good.
All right. Thank you very much for the kind introduction.
You should be able to share now.
Yeah. All right, there we go. So the work I'm presenting today was also done with SpeechBrain as all the other work, but with the focus of end-to-end ASR for continual learning, fine-tuning on financial data set and other diverse data sets. So yeah, I am working with JP Morgan, specifically organization within it called MLCOE, or Machine Learning Center of Excellence, and all of the opinions in that presentation are my own. Yeah, as Mirko said, I worked on some of the early development of SpeechBrain, and then when I graduated from OSU, I joined first Chase to do real-time transcript analysis, and then I moved to MLCOE to develop speech technologies. So what is MLCOE? Well, Machine Learning Center of Excellence works with different JP Morgan Chase teams within the company to solve machine learning problems. Basically, people come and ask us to help solve their problems, and then we provide machine learning solutions. We have a wide variety of requests, and some of them include speech. For example, call centers, real-time analytics, or legal team, or you name it. There's probably a use case in the bank for it. We have a number of different sub-teams within MLCOE that can do a large number of, solve a large number of different tasks. And if you're interested in joining, we are actually hiring right now. So feel free to speak to me after the presentation if you're interested. So why continual learning for an end-to-end ASR? Well, there's a large number of well-trained open source models from different organizations, OpenAI, Whisper, NVIDIA's NeMo Conformer, ESPNet, and SpeechBrain all have large pre-trained models that are performing well, but they don't always perform well on bank data sets, especially when we have certain challenges like financial jargon or specialized language, company names, acronyms, regional accents, and so on. So we want to fine-tune these models, the end-to-end models on our bank data set without forgetting any of the things that were learned during the original training. So how can we fine-tune without forgetting? So ideally, we take the open source model and test them, find the most suitable, and then fine-tune on bank data. And when we have fine-tuned based on all of the available data, we make a productionized version. And then as new use cases come in, we may want to further fine-tune on new use case data. And all of this data has a time limit before, amount of time we're allowed to store it. So we may have to, a limited window in which to fine tune, and we won't be able to revisit the data after we've done that. So this is why continual learning is a good use case for the bank. So different current approaches have various weaknesses. Some approaches still have some amount of forgetting, which if we go far enough out, we may, the amount of forgetting may be unacceptable. A data replay, like I said, data may not be available. Adapters mean that you have to maintain a different set of parameters for each use case. So what we want is a single model that is good performing for all of our use cases. So our basic approach is the following. Basically, instead of continuously tuning on new use cases, what we do is we take the original generalist model and fine tune on each domain or use case independently, and then take the average of the result. It's sort of a different paradigm in how to do continual learning. And this way you can add as many new use cases as you want, and you don't have to worry about eventually reducing the performance. So we ran experiments using OpenAI Whisper and Nemo Conformer, as these are two good performing open source end-to-end models with slightly different structures and objectives. And then we experimented with 3 different data sets that have a variety of properties. SPGI is an earnings call data set. It's large, but it also has financial jargon and company names and so on. Then there's Corral, which has 140 hours with African American speakers. It's more conversational, and obviously has some accented and dialect. Then there's Dinner Party Corpus, which is 5 hours of very small with background noise, so very challenging data set. So with these data sets, we implemented a few baselines, including layer-wise learning rate decay, which changes the learning rate based on the layer. We implemented updating only encoders and learning without forgetting. What we found is actually learning the LLRD was as good as any other approach, and we used that as sort of our starting point. And we're trying to build on top of LLRD. From the table, you can see that adding it improves the performance both on Corral and on Libre speech, which was we used as our sort of testing how much forgetting there is. Then we continued with this is the conformer model. We experiment with the freezing layers approach, and we found that frozen layers was equivalent to reducing the learning rate if you were using LLRD. So no benefit from that. So basically the point of this is LLRD is our sort of starting point, and then we're trying to improve on that. So for our results, we found that training sequentially on the 3 data sets resulted in substantially different performance depending on the order of the data sets. And the best average performance, including the pre-training data sets, Libre speech, was achieved with averaging, fine-tuning on each data set independently, and then averaging the results. So this approach avoids forgetting substantially more than the other approaches and gets reasonable performance on all of the data sets. And finally, OpenAI Whisper, we do the same thing, and found it was a little more susceptible to forgetting. We had to use a couple of tricks like reducing the ratio of weights from layer to layer, as well as reducing the size of the FPGA dataset. But we were still able to use it effectively to achieve relatively good performance on all of the datasets that we tested, including the two liver speech datasets that were in the pre-training set, but not in the fine-tuning set. Yeah, that's pretty much it. The one last point is that domain experts might have permuted weights, so we could get some improvements by rearranging the weights before we do the averaging. So there's a couple of works that have tried to do this, and it may help in this case as well. So that's some of the future directions that we're looking at for this work. Any questions?
Any questions from the chat? If not, I can ask one maybe. So why do you need to do continual learning? Like, can't you just like train everything at once, or is it too large?
So there's a number of, yeah, that's a good question. So there's a number of points here. One is for these open source model, or the data, the model themselves may be open source, but the data may not.
Right.
So for Whisper, yeah, we can't fine tune on any of the data that they used because it's not available. The second point is these data have a limited lifespan. So according to a lot of company policies, you're only allowed to keep transcripts around for 6 months or a year or whatever the limit is, and then the data won't be available anymore.
Yeah, you lose access, so it really fits the CL framework, right?
Yeah.
But like if you do something like rehearsal, would you be able to retain some of the examples, or no? Right, you completely lose
Yeah, I don't think that should be possible.
I see. I see. Okay. Any questions from the audience? No. Well, if not, I guess we can move on to the next speaker. Please, let's thank Peter for the great talk. Oh, Salah has one question. Yes, Salah. I can give you access 1 second. Actually, you should be co-host, so you should be able to ask yourself.
There are two questions.
Oh yeah, thank you. I just had a question on the shift. I mean, I guess the shift is mainly textual, not acoustic. So, what about just methods for textual shift handling? Like, I've seen a lot of those into removing internal language models, replacing them with external ones, or even like rescoring language model rescoring afterwards. Have you tried those? This is my question.
Yeah, of course, we are also looking into contextual biasing methods for, like language model rescoring for dealing with the problem of like specialized jargon or words like this. but actually, so far in our experiments, the fine tuning is actually a lot more effective. So we will continue to approach on both fronts, but fine tuning is actually really important in some cases.
Thank you, Peter.
Okay, Mirko, you had questions?
No.
Oh, I thought you said 2 questions. Okay.
Yeah, but in the chat, take a look at the chat, right?
Oh, okay. In the chat.
I have one question and a small question. So
Oh, okay. Yeah, Salah. Yeah, Diani. Yeah, what's your question? So maybe I can give you 1 second. Maybe yeah. You can write your question. One second, I'm trying to find your name so that. I just gave you voice access.
Hello. Yes. Thank you. I was actually typing my question. Thank you for the presentation. My question is that since you said that continual learning you used because the data was very limited and it was not easily accessible, or there was some restrictions also to the usage. I want to know if continual learning for end-to-end ASR training on Whisper would also be possible for low resource languages, which might be available open source, but since they are very limited in the span or the availability of the data sample itself, could also be a possibility to use this methodology.
Yeah, if you had, so I'm not sure what the result would be if you used, like, for example, 2 data sets of different languages, but if you had two open source data sets of the same language, then yeah, I think this approach could be a reasonable one.
Okay. And also, could it be like also make sense if they belong to the similar family of languages but are not the same languages, so to say?
Yeah, I mean, I haven't personally, I don't have too much experience with training on other languages, but I don't see any reason why it couldn't work. So yeah, I would say try it.
Okay. Yeah. Thank you. Thank you.
Okay, do we have maybe one last question? Last 5 seconds. 5, 4, 3, 2, 1. All right, that's it, I guess. Thanks, Peter, for the talk.